Okay, team. So, welcome to the session on Docker fundamentals. So, my name is Krish. I'll be talking about this on this workshop. And before I start the session, I would like to give you an introduction about my profile. My name is Krish, and I am working at InfosecTrain as a senior technical consultant. And I basically hold an experience of around 17 plus years on various domains in IT. And from 2010 onwards, I am working in cloud computing, especially the AWS and Azure, etc. And I consult for a lot of companies worldwide for migrating their infra to cloud platform to support them to their cloud management activities and cloud security process. I do trainings as well. I train for cloud security architecture, cloud offensive pen testing, and all these kind of things. So I work in, as we discussed, I'm working as InfosecTrain. And to give you an idea about InfosecTrain, we are started in 2016, and we provide training and consulting for various IT and cybersecurity domain areas. And we are in the industry for the last 4+ years of service, and basically we have a huge amount of trainers, and we are specialized in security, plus we deliver the other technologies as well. Okay, so let's start now. So today's agenda is this. Okay, so we are talking about what exactly is a containerization and what are the benefits of it. Then we'll talk about what is Docker and how to install and configure the Docker. And then we'll talk about creating the containers, like how to create a container or how to deploy a Docker container specifically. And I will tell you how to manage all these things in an easier way. Then we'll tomorrow we'll go for the storage and networking in Docker, and I will tell you the advantages and drawbacks of deploying these containerization platforms in the cloud platform. Okay, that's a plan we have. So I'll be showing you almost all the things in hands-on. Like I will show you from the very first, like how to deploy a Docker container and how to install this Docker, how to deploy a Docker container, and the basic management things and all. I will show you in demo. Okay, this is a very fundamental session which is intended for people who is not aware of the concept of containerization. Okay, so let's start now. First of all, team, I won't tell you about a few things on this. What exactly is a container? So now this term is basically there for a last 5, 6, 7 years. Like you're all familiar with this term called as containers. But what exactly is a container? I have seen that many people say that Krish, when this containers came into market, there was a concept of virtualization, or there is a concept of virtualization, and this particular technology got outdated. I have seen many people tell me the statement that there is a technology called as virtualization and it's outdated, and now there is a containers everywhere. Okay, but what I want to tell you is that containerization is also a kind of virtualization. Okay, is also a kind of specialized virtualization, but we have a lot of differences. Okay, so first of all, I will tell you what exactly is the concept of virtualization. So team, why do we go for a virtualization? Like for example, let's say now when you talk about the cloud computing platform or cloud like AWS or Azure or GCP or cloud platforms, when you talk about data centers, when you talk about any industry requirements in IT, okay, this virtualization is a must have. Okay, this virtualization is actually a must have. Do you know why? Like for example, when I basically go to the cloud platform, like for example, team, how much time it will take for you to deploy a server in the cloud platform? Like just asking you, team, tell me how much time it will take for you to deploy a server in the cloud platform?
Few
2 minutes?
minutes.
Yeah, just a few minutes, right? Like 2 or 3 minutes maximum. Okay, like you can just go log into the cloud platform, make a few clicks, and it's done. You're able to deploy the servers or storage or anything in the cloud very faster. Okay, so this is basically what we call as a on-demand self-service. Okay, this capability of cloud is called as a on-demand self-service. So what I want to tell you is that this capability of cloud computing is basically there only because we have a feature in the cloud, or the cloud is using a technology called as virtualization. See, like now I'm going to my cloud platform, let's say AWS. Okay, I'm going to my AWS cloud platform. It can be anything, any cloud, AWS or any cloud platform. So when I go to the cloud platform, let's say I open a service and I want to deploy a server in it. Okay, in AWS we call it as instance, but I want to deploy a server. So when you say the word server, it's basically different for all of us, right? Every one of us is having a different requirements for a server. So now I'm going to deploy a very simple server in the cloud platform. I click on launch instance. I will first of all choose the operating system I want, whether if I want to have a Windows or Linux or Mac, I can choose the OS I want. So I have choose this OS. Then I will choose what kind of hardware configuration I want. See, you can see a massive amount of configurations here. See, there is a huge number of configurations you can see here. Do you think it's possible for the cloud service provider to set up a physical server or to set up a complete physical server machine for you when when you click on deploy? No, it's not possible for the cloud service provider to deploy a server in a matter of minutes when you say, because millions of companies worldwide is hosting trillions of servers simultaneously in the cloud platform. So how can you basically, or how can the cloud service provider allocate a physical server for all of them? That is why in cloud also the virtualization is the heart of the technology, because that is the key underlying technology which basically runs the cloud platform. Okay, the same thing is basically used in containers as well. So let me tell you what is a virtualization. So normally what we have, like for example, if there is no virtualization, okay, so we have a computer here. This is my computer, my physical computer, my hardware, actual physical hardware, my CPU, my monitor, I have a keyboard and mouse. So I want to deploy an application on it. Okay, I want to deploy an application on it. So when I say I want to deploy an application on it, first of all, I have to install an operating system. Let's say either one. I cannot install both of them simultaneously and work on both of them simultaneously, right? So I have to either use Windows or Linux or something like that, right? So I have installed, let's say, Windows on it. Okay, Windows on it. So basically what happens once I install Windows on it, okay, once I install Windows on it, on top of it, I have to first of all install the platform like PHP or Java or .NET or Node.js, and then I have to host my website. So like this, for every application, I have to deploy multiple servers, right? For every application here, I have deploy multiple servers. And do you think it's a benefit? Like, what is the problem with it? It will take us a lot of cost and effort, right? For deploying multiple physical servers, you have to pay a lot of cost, plus there is a lot of effort and all these things, right? And most importantly, the biggest problem is that, team, if you check your system now or my system now, do you think that you are completely utilizing your capacity? Like for example, now I am opening my task manager in my laptop. Okay, do you think that in this laptop, if I am using my 100% capacity everywhere? No, right? See, even if you check your laptop also, even if you check my laptop also, the servers also, the storages also, in 90% cases, you are not using it effectively. You're not using it properly. You're wasting a lot of resources, right? So that is where this technology called as virtualization came in. That by using virtualization, what I can do is in a same physical computer, in a same physical server, I can deploy multiple virtual computers, multiple mini computers, or let's say multiple virtual computers, which we can call it as a virtual machines. Okay, virtual machines. And like the same way I have a physical computer, I can install an operating system on it. I can install applications on it. I can troubleshoot it. I can basically do a lot of things, right? It's possible for me to do a lot of things on it. Okay, that is what we call as a virtual machine. When this technology came, it was a revolution because it helped a lot of companies save a lot of space, save a lot of electricity, save a lot of effort, cost, a lot of things, right? So now I am going to tell you how this virtualization is beneficial for us. So this is my physical computer. Okay, this is my physical computer. Like it can be a laptop, it can be a mobile phone, it can be a server, it can be a PC, it can be an iPad, whatever it is. I'm having a hardware. On the hardware, see, let's say I will take the example of my laptop. It will be much more easier. So currently I am teaching you, I'm currently taking the session from a laptop. In my laptop, you can see that I am having an operating system. Okay, in my current laptop, I am having an operating system, which is basically using Windows. See, I can show you that. See, currently I'm using a very basic laptop, and in my laptop, I'm having a Windows C. I'm having a Windows operating system. Okay, so when I am having a Windows operating system in it, okay, so on top of this operating system, I can install a software. Okay, I can install a software which we call it as a hypervisor. Generally, we can call it as a hypervisor. So now this is my laptop, which you see, and on top of this, I have an operating system. On top of my operating system, I can install a software called as a hypervisor. So you can see it here. Okay, you can basically see it here. Just give me a second. So I'm opening a hypervisor software which I have already installed. Okay, there are many softwares like VMware Workstation, Oracle VirtualBox. So this is a software called as a VMware Workstation. It's a paid software. You have to pay for this because it's a enterprise version. So this is a VMware Workstation. Like the same way we have a software called as a VMware Workstation, we have another tool called as a VirtualBox. It's a free of cost. So these two things you see here are two different hypervisor softwares. So now the question. So Krish, why do I need a hypervisor? Let me answer the question for you. So I'm opening an application here. Just give me a second. So this is my laptop, or this is the server. Okay, I'm just I'll draw these things here. Let's say this is my physical hardware. So on top of this physical hardware, okay, on top of this physical hardware, I have a operating system. That is what I just told you now, right? I'm having a operating system. Like in my case, it's Windows, so it can be any operating system. On top of this, you can see a hypervisor software which I have now installed. Okay, now there is a hypervisor software. And why do we need a hypervisor software is the next question which we have. So as I told you that we are deploying multiple virtual computers on it, or I am deploying multiple virtual machines on it. This is a virtual computer 1, this is a virtual computer 2. Like this, I am deploying multiple virtual machines here, right? Each of these virtual machine act as a complete physical machine. Don't forget, each virtual machine or each VM act as a complete dedicated server or dedicated machine. So when you turn this on, you can basically switch the server on, you can turn it off, you can restart it, you can install operating system. So I will show you that anyway. So once we deploy the VM, it acts as a separate computer. But how can it work like that? How can it share this hardware effectively? By the help of a software called as a hypervisor. You are doing the virtualization with the help of a software called as a hypervisor. The common examples I just showed you now, we have a Oracle VirtualBox, we have a VMware Workstation, etc. Now I'm going to show you how to deploy a simple virtual machine. Okay, so I am using the VMware Workstation for that. You can use any tool, no problem. This is the tool called as VMware Workstation. Okay, as of now, I already have a OS installed, but I'm going to deploy one more virtual machine here. I'm clicking on new virtual machine. So they're asking me, welcome to the new virtual machine wizard. I'm going to deploy a virtual machine. So now they will ask me which operating system I want. They're asking me which OS I want. I'm telling them that I will do it later. So I click on OK, next. Then they will ask me which OS you are planning to install. Team, do you know why they're asking this? Because they want to configure the hardware, or they want to optimize the hardware. Okay, they want to optimize the hardware, or they want to configure the hardware. Okay, for Windows or Linux or Mac or whichever OS do you want. I'm saying that I'm planning to deploy a Linux on this. Okay, or you can say anything. Now there is a question. So Krish, if I choose Linux and if I install Windows, it will work. Yes, it will work, but maybe in some configurations it can show some error. That's all. So now they will ask me where to store the image name or the VM. So I can store my VM in my local laptop itself. Then they will ask me how much storage I want. They are going to create a virtual hard disk for me. See, they are going to create a virtual hard disk for me. Now my question is that, team, from where they are getting this 20 GB size? Tell me, Or let's say if I'm saying 100 GB, from where they are getting this 100 GB size, team? Any idea? From my actual laptop, right? From my physical laptop storage. Let's say, for example, in my laptop, I am having a 1 TB SSD. From my 1 TB SSD, they are creating a virtual storage or virtual hard disk or virtual SSD, which is 100 GB size. And let's say, for example, for as of now, I'm creating 2 GB for your convenience. Then they are asking me how much RAM I want. See, they are telling me that they will take 4 GB RAM. So team, from where this 4 GB they are getting? So from where this 4 GB they are getting? This 4 GB they are getting from the actual computers, actual physical hardware's memory, right? That's it. So once you click on finish, what happens, team? Once you click on finish, within the next few minutes, like within some 2 or 3 minutes, the virtual machine will be created. Then you have to install the operating system on it, and it's done. Okay, this is how the things are happening in it. Okay, that's it. So it's a very simple job, and you can create multiple virtual machines here, and you can basically start them, we can start them, we can restart them, we can configure the memory, we can add more storage, we can add more memory. So you can basically work exactly like the physical computer. The only difference is that all these things will be virtual. Okay, this is the concept of virtualization. So I can show you some example by turning on this VM. So this VM I have already deployed. Okay, this is a Linux called as Kali Linux, which is used for security and hacking purposes. So I'm just powering in this VM on. I'm clicking on this power on this VM. So it's now turning on. It's like this normal system boot up, nothing more. It's just exactly like the normal system booting up. See, there is no difference. Okay, it's exactly like the normal system booting up. See, no difference is there. Now they will start the computer. It works like an exact same computer. If you basically, I can show you an example also if you want. Please wait. It will start now. Yeah, almost done. See, one problem have you noticed, team? When you turn on a VM, it is taking a lot of time to boot up, right? See, anyway, I have just got the screen. I'm typing the username and password. I guess this is a username and password. I'm going to log in. So once I log in, it is a separate computer. Whatever things I do on this computer will be inside this Kali Linux machine only. It is not inside the. It is not in my physical machine. So I can browse the internet. I can basically open terminal. I can basically do whatever things I want. This computer will be entirely separate. This computer will be entirely different, right? This is the concept of virtualization. But there is one more thing I just want to teach you as a part of it. Let me turn this laptop off, or this virtual laptop off. So it's now shutting down. Okay, it will shut down now in the next, let's keep it aside. Done, it's turned off. Okay, perfect. Now this is what we call as a simple concept of virtualization. There is one more thing. This is a very interesting concept, and which we just showed you now, but there is a small difference. If you go for an enterprise scenario, if you go for a complete enterprise scenario, the biggest problem you will face is that, team, see, there is a server here. It can be a server as we discussed, or a laptop, whatever it is. On top of it, you have a operating system, right? It can be either Windows or Linux or whatever it is. There is an operating system. Okay, Windows or Linux or anything. And then you are installing this hypervisor as a software, like VMware Workstation, Oracle VirtualBox, etc. This is your virtual machine. This is your complete VM. Like you have Opera OS on it, you have a application on it. So it's a complete VM, right? All these things are complete VMs or virtual machines. So team, what happens if this OS crashes? Let's say this OS, this particular operating system crashed, or maybe my laptop OS or my laptop OS got the performance was very slow, or it crashed, or something went wrong. So basically, what will happen to my VMs? Tell me.
I think you lose all the
We
image
lost
or all
complete
the.
VMs, number of VMs we
We
created.
will not boot up, Chris, then.
in that case.
So anyway, from all these things you said, the whole infrastructure will go down, right? That means the whole VMs will go down, and the whole hypervisor will crash. The data may be lost. So end of the day, things will get messed up. Plus, more importantly, this is a complete operating system. So what happens if there is a malware infection for this laptop? It will affect, or virus infection, we can say. It will affect all these VMs and all these things, right? Everything is gone. That is why there is one more kind of hypervisor we are having. There is one more. So this is basically what we call as a type 2 hypervisor. Type 2 hypervisor. Okay, where we have a OS and we will install the hypervisor software. Now, there is one more type which we use in the enterprise. When you go to the organizations or when you go to companies, we will use a more advanced version of this. We call it as a type 1 hypervisor. Type 1 hypervisor, or we can call it as a bare metal hypervisor also. So there it is called as type 1. Okay, type 1 hypervisor. What is a type 1 hypervisor? That means that this won't be there. There is no operating system. You're installing the hypervisor software directly on this particular hardware. So it's a more of an enterprise level. We can basically do a lot of things, lot more things than you can imagine on this. So that is why in the enterprise level we will go for this. Even if you go for a cloud service provider as well, they are also using this one. Okay, in the
Chris,
backend.
Chris, on physical hardware without
Mhm.
any OS, can you install Type 1 hypervisor? Something should be
100
there, no?
Nothing, 100% is because the hypervisor itself will act as a operating system also. Like for example, the
Okay.
best example is VMware ESXi. It's a very common hypervisor by VMware. So basically what happens, this is a very small tool. So you are installing the hypervisor software uh, directly to the hardware without any OS. I 100% no OS, and there is a very mini OS inside this itself by default. So because of that reason, you can install the hypervisor software like you install a OS. Okay, that's it.
So what happens if it crashes the hypervisor? What will happen?
Okay, okay, that's a very good question. So team, now, Krish, what happens if the hypervisor crashes? It can definitely happen. So that is why when you go for a type 1 hypervisor, they allow you to create something called as a clusters. Type 1 hypervisors allow you to create something called as a clusters. That means that I can create, okay, I'm just going to show you a new picture here. I can create, this is the example of a type 1 team. I'm just showing you a simple example. Just give me a second. Give me a second, team. Sorry, there's some issue. Yeah, now it's fine. So team, see this. This is one computer, one physical computer. Okay, this is another physical computer. This is another physical computer. So I can make a cluster like this. So what is the benefit of creating a cluster? So this is a virtual machine number one. This is a virtual machine number two. Like you said, let's say for what happens if the hypervisor goes down. Just in case if you feel there is any something going wrong or if the hypervisor is going to crash, the type 1 hypervisors, not the type 2, type 1, the advanced level, bare metal type, will allow you to move the virtual machines from this computer to another machine with a hypervisor. They basically allow us to migrate the VMs from one particular physical hardware to another, so that what happens, even if this crashes, my VM is safe. So it's a complete failover is there, plus complete clustering is there. So because of that reason, I don't. So this is my physical server number one, physical server number two, physical server number three. So even if one hardware is basically going to fail, I can always move my VM from one machine to another. Basically we call it as in VMware we call as vMotion. Got it? Yep, that's it. Any other queries, team? This is about the virtualization concept. Any doubts you have in this? Anything? Okay, the key difference between type 1 and type 2 is that in type 1, what you have in type 1, there is no OS between the hardware and the hypervisor. See, there is no OS here. The hypervisor is directly installed on the hardware. If you go for a type 2, you have a hardware. On top of it, you will install a operating system like a Windows, Linux, whatever it is, and then you will install the hypervisor software. Then you will install the VMs on top of it. Okay.
So, Chris, just one more query here. As we
Yep.
have a common hardware between two VMs, right? So, all the data which is getting saved by end users
Okay.
finally reside into the hardware only, right?
Not
Okay,
exactly.
VM1.
See, all the data in the hardware. See, end of the day, when you say, even if you are saying virtual machines and all these things, this is only residing inside your inside your hard disk only. So basically, what happens? All these things are inside your normal storage only. Yes.
Right. So if something goes wrong with even hardware, so all the VMs got data loose, right?
Yeah, that is why what we do. We will have a cluster. Plus, we will not use the storage in this hardware. We will basically make a SAN cluster here, and we will basically map the storage from the SAN cluster only. So that here we already have redundancy and all these things. Okay.
Okay. So like we do
So,
vMotion, hardware also can be managed like this. Yeah.
Yeah, yeah,
Okay.
yes, yes, yes. And Surur, yeah, answering your question, Surur, in Windows Server failover clustering using Hyper-V. So, team, that's a very interesting point. Okay, see, what in Type 2 also you may have a clustering concepts, okay, but not effectively as a Type 1, because in Type 1 you can move a live running virtual machine from one system to another. It's not possible in Type 2. Plus, Type 2 is basically designed for basic purposes. And one more very interesting information. One more very interesting information. When you go for a Hyper-V, there's a software called as Hyper-V. Team, tell me, Hyper-V is it a Type 1 hypervisor, Type 2 hypervisor? It's a
type 1, I
type
think.
it's a Type 1 hypervisor. We even so Krish, it's installed on a system. You can install some mini version of it on the system, but still in real time, in the pure version of Hyper-V is a Type 1 hypervisor only. Okay, that's it. Okay, what is the minimum system? You can, if you, and you can do it with the 4 GB RAM itself. Like if you have 4 GB RAM, you can basically deploy some VM. See, in my laptop, I'm having 16 GB RAM, so I have two hypervisors installed on my laptop. You can see it here. Just give me a second. See, so one is now running. So I have a Kali Linux which is running, and I can basically create multiple virtual machines here, and I can run out, no problem. If you want to basically create one for yourself, you can basically do it using a tool called as a Oracle VirtualBox. It's an open source tool. It's a free tool. Okay, we have a tool called as a Oracle VirtualBox. That's it. This is about the
Krish,
virtualization.
and this
Mhm.
hypervisor in type
Okay.
1,
Okay.
what OS using to build this one? Maybe it's a Linux
Anything,
itself, or
anything. See, now my laptop is Windows, right? My laptop is Windows, so you can basically have a Windows or Linux, and now also Mac is also supported. So basically what happens, you can do it on Windows or Linux. See, currently in my laptop, I'm using Windows, so I'm on top of it, I have installed the hypervisor software like workstation and all these things, right? That's it.
yeah, no, no. I mean on the type 1,
Type 1,
maybe
there is no
mostly
there is
it's a
no
Linux,
OS, right?
right?
No, there's no OS, right? But the hypervisor softwares are built using Linux, that's all. But there
Linux,
is no
yeah,
OS
that's
separately.
my
Yeah,
question.
yeah, yeah.
Yeah.
Linux kernel, actually, not Linux, complete
Okay.
Linux, the actual Linux kernel.
Can
Yeah,
okay.
yeah.
Okay.
The last question on hypervisor software,
Okay,
is it free
okay.
open source or you have to pay for license?
Okay, so it's based on the software. Like for example, let's say if I go for the tools called as this one, like I'm talking about type 2. Okay, type 2, if you go for it, if you go for something called as a let's say Oracle VirtualBox, it's free. It's completely free. If you go for VMware Workstation, it's paid. Okay, and team, I personally, there are many reasons I don't recommend anyone using a cracked version of the software, is because it can cause you a lot of trouble anyway. But if you go for a type 1 hypervisor, like the more enterprise level thing I told you, if for this we have a VMware ESXi, it's paid. It's really costly, but still it's really good to learn also. Then we have a KVM hypervisor, a lot of things. Like KVM is free, like that we have many tools on that. Okay, that's it. Yep, cool.
Thank you.
Yep. What I personally recommend is that it is enough for you to use a free version of your open source version of, because I am running some 3 or 4 servers 24/7 on an open source hypervisor. It won't make any challenges to us. The only thing is that the way you manage. Okay, that's it. Cool. So team, that's about the VM concept. Okay, I just given an introduction for the first few minutes regarding the VM. Uh, you can install Type 1 hypervisor on the laptop, but the problem is that you cannot install any of the softwares on that. Like you cannot install any of the OS on that. Else you have to make a lot of tweaks and all. It's a bit tricky. Yes, but I don't recommend that. See, even I can tell you one very interesting scenario which I have personally done. Team, have you heard of something called as a Raspberry Pi? It's not the eating thing, it's a device. It's a small computer you can buy. Okay, It's a very, very small computer. It's very interesting, Qt Pi. It's really good. So if you, yeah, it's not a I am not saying it's a complete micro, but still, this is a very good computer. It's a complete computer. What I will do is I have deployed some 4 type 1 hypervisors on 4 computers on this Raspberry Pi. See, we have a RAM choice and a lot of things like that, but still just for training and learning purpose, not like for enterprise purpose. It's not a big deal. It's not a big thing. Okay, that's it. Yeah, just like, but Arduino is, this is but much more, efficient for these kind of purposes. Okay, that's it.
So,
All good, team.
so type 1 is also called bare metal hypervisor, right?
Type 1 is also called as bare metal. Type 2 is called as hosted hypervisor.
Okay.
Yep. So any other queries, team? All good? Yeah, Pratik, tell me.
Well
Yeah,
explanation.
yeah, good, yeah.
Perfect. Okay. Now let's go back to the container thing. So why do I explain this virtual machines or virtualization a concept like this? The reason is because I want to show you the advantage of having a containerization. Okay, I won't tell you why we are adopting new technologies. Okay, that's it. Like for example, first of all, like for example, now, let's say now you in your home you eat food in a plate and you just cook your food and all. Okay, and after that you wash your dishes, right? You wash it. It's very easy. Like you just take your dishes and you wash it. Or there is a new option. There is an option we call as a dishwasher, right? There is a device called as a dishwasher. What is the advantage of it, team? Like it basically avoids that hectic task of rubbing that all these plates and all these things, and you can it'll clean for you, right? But is it possible for you to do everything with this dishwasher? No, right? Like the same way, we have a more convenient version of virtualization called as a containerization. Okay, but it's not a replacement for virtualization, but we can do many things on containerization which can be done by virtualization as well. Okay, that's it. So first of all, I can tell you some advantages of virtualization, and now I am going to talk about some drawbacks of virtualization as well. Okay, the primary drawback of virtualization is that, sorry, the primary advantage is that, as we discussed, you can run multiple virtual machines on the hardware. See, now in my laptop I'm having a 16 GB RAM. Okay, I'm having a 16 GB RAM. My Windows operating system I'm having will take only some 2 or 3 GB maximum. So all, even if it takes 6 GB, I am having 10 GB left, right? So I can create 5 virtual machines with a 2 GB size. So like this, I can create multiple virtual machines here if I want. No problem, nobody will ask me, right? It's a very easy thing. It's more flexible. It's very easy for us to manage. I can simply troubleshoot. I can take snapshots. Team, what is a snapshot? Like for example, let's say now assume that you're running a VM. Okay, you're running a VM here. Okay, so let's say you want to take a status of the VM state. So if you click on machine, or you can just click on take a snapshot. Okay, so when you basically click on take a snapshot, what happens, team? This will take the snapshot of this VM. Snapshot means what? It is just an option where you're able to take a current state of the VM. Okay, you're able to actually take the current state of the VM. So basically what happens, once you take the current state of the VM, it'll store it like that. So next time, okay, you do something wrong, something went wrong, something wrong happens, what happens? You can always go back to the previous version. See, for example, let's say now I am currently running this VM. There is something wrong happened, there is some issue happened. So I can basically do a lot of things. All I have to do is just go to the snapshot settings. I can basically restore from the snapshot. I can basically go back to the previous state of my VM. Okay, like this I can do a lot of things. Anyway, VMs are a very good thing for the industry, but these are the challenges which we have as a developer, or as a when you work in enterprise. These are the key challenges which we are having. Okay,
Hey, Krish,
tell me.
sorry to interrupt. Just,
Yeah,
just a
Vikram, no
quick
problem.
question.
Yeah, please.
So, yeah, let's say if I have my the underlying server, let's say it has a 8 GB memory, okay, and
Okay,
I have hosted 4 virtual machines on the top of it. Each has
okay,
2 GB worth of
okay,
memory.
okay,
Is there a way, let's say, for example, one of my VM is kind of, utilizing full 2 GB. So, and the
okay,
other VMs are utilizing less memory. Is
okay.
there a way of sharing this although I have just dedicated 2 GB to this VM1, but
Okay.
in case I'm running out of memory on this particular server, is there a concept of sharing this
Okay.
resources?
Got it. So
Do
first
you
of
get my
all,
point?
no, got it. So first of
Okay.
all, to answer that, first thing is there is a word which I always use. Whenever you are creating, you are allocating the memory, you're allocating the resources to a VM, like for the storage, the memory, the CPU, all these things you're allocating. That means that until you deallocate, until you deallocate these things, they still it basically belong to that VM only. But still there is a word called as dynamic memory utilization. That means you can basically have a common shared memory which can be utilized by multiple VMs, but that is very limited. Plus there is a lot of drawbacks also for it, like sometimes it can keep a buffer, it can show you some errors. For some enterprise critical applications it is not trustable worthy. That's why we always go for allocation options. That's it. Okay.
Okay. All right.
Yep.
Thanks.
Yep. Now, coming back to my VM drawbacks. The drawbacks of VMs. The first drawback which we have is a huge resource utilization. So let me just give you a very interesting point. When you say the word huge resource utilization, okay, I can tell you the key point of it. Like, just give me a second. So now let's say this is my computer where I am having uh, 8 GB of RAM. Okay, here I'm having a 8 GB of RAM. Out of the 8 GB of RAM, there is a VM1 here and VM2 here. So in this VM1, I have allocated 4 GB of RAM, and VM2 I have allocated 4 GB of RAM. Okay. So, and there is some application running on top of it. So these applications are totally using maximum 2 GB. Let's assume that these applications are only using 2 GB in one computer and 2 GB in another computer. Like the question that just now he asked, the rest of the memory which is basically there, like out of 4 GB, only 2 GB is now currently utilized. The rest 2 GB is not effectively utilized. That means 2 plus 2, that totally 4 GB of this physical hardware. Okay, 4 GB of this physical hardware is currently not effectively utilized. It's wasted. Okay, that is one problem. The second most problem is that whenever you are deploying a virtual machine, okay, whenever you're deploying a virtual machine, can you see something here called as a OS on it? See, you can see there is a OS on it, right? That means what? When you deploy a virtual machine, or when you say the word called as a virtual machine, in every virtual machine, you will have an operating system. Okay, now let's say I am currently just creating a VM on this my uh, software. Just give me a second. This is my hypervisor software called as Oracle VirtualBox I showed you. I'm going to create a new virtual machine here. Okay, so I'm going to create a new virtual machine here. So new virtual machine, I'll give a name for it, like sample server or sample VM something, and I'm just selecting some it's basically I want to have a Linux one. I'm not a big fan of Windows actually. Anyway, I'm just taking this. Okay, I'm using, okay, I was trying to using uh see this, I'm allocating 1 GB RAM from my laptop. So team should tell me why they are showing only 16 GB RAM here. You can see that they are only showing 16 GB RAM here. Why can't they show more?
Because your main hardware has 15 GB RAM only.
Exactly, my underlying physical hardware have only 16 GB RAM. So what happens is that team, so I'll just use 1 GB as of now to show you an example. So click on next. I am going to create a virtual hard disk. So it's mandatory for you to have a virtual hard disk. So just a second. So just let's say I'm creating 2 GB for the convenience, but 2 GB is not a good idea because creating a 2 GB is, nothing will work on it. But just an example. Okay, now my VM is deployed. See, I was able to deploy a VM, but now comes the next part. I'm trying to start the VM. I'm powering on my computer, which I have assembled now. Let's see what happens there. Once I click on the VM, once I click on start there, Let's see if there is any problem. Just wait. It will take some time to start anyway. Okay. See, it is now getting started. Okay. See, it is showing me that. See, it's now starting up. See, this is a boot screen. So fatal, no bootable medium found. That means what? You have to install. Okay, you have to install an operating system on it. First of all, you have to insert a CD or image of it. Then you have to install the operating system. Then only this VM will start. Okay, so you have to have a complete. You have to have a complete operating system on every virtual machine, right? That's the biggest problem. Okay, you have to have a complete operating system on every virtual machine. So it is a huge load, right? Like, let's say for example, this is a hardware I'm having. Okay, just think about this, team. This is a hardware I'm having which is having 16 GB of RAM. I'm giving 8 GB RAM to this, 8 GB RAM to this. Out of the 8 GB RAM, the OS is taking 4 GB RAM. Okay, the OS is taking 4 GB RAM. Okay, then the application is taking 2 GB RAM each. Okay, so basically what happens, team? I'm just wasting my total 8 GB of RAM only for operating system. Just think about this, right? So what happens, team? It is a huge resource utilization we are having. Yeah, Pratik, I'll come to that. Yeah, okay, it's a huge resource utilization. I will come. Which we are having. Okay, first problem. The second thing is that you have seen the boot time, right? When you want to turn on a VM and when it boots up completely, it will take at least 2 or 3 minutes, right? The VMs will take at least 2 or 3 minutes, but when it comes to servers, it will take more time, right? It will take at least 2 or 3 minutes to boot up minimum. Then as you have a guest OS, so team, like for example, what happens if the host OS is compromised, or what happens if the underlying OS is compromised? There is a OS here, right? What happens if this OS is compromised? As we discussed before, everything will be gone. Okay, like the same way, you have to install, update, patch, secure, manage, maintain, and operate all these OS, right? It's your responsibility to manage and maintain and troubleshoot and manage all these OS. So you have a lot of overhead. You have to basically manage all these things. You have to troubleshoot. You have to do a lot of things. Okay. So I'm just trying to tell you the drawbacks of VMs. Okay. Now the next thing. Okay. We have something called as a platform dependency. Okay, platform dependency. So what is a platform dependency, team? So that's a very important point. When you say the word platform dependency, it means that, see, you are hosting an application on this VM. So now I'm telling you, team, this app, so let's say for like this application is hosted on Linux. Team, is it easy for you to move this application to Windows easily? Let's say this is Linux, this is Windows. Is it possible for you to move this application from Linux to Windows easily? Okay, let's say we have an
No.
application. No, right? It's a hectic task. Like, the application hosted on that particular VM is completely dependent on the OS. So because of that reason, we cannot basically port it easily. That's what we call as a platform dependency. And the next point is that, now let me give you a real-time organization scenario. So we have a developer here. This is my developer. So this developer is developing an application. Like, he is developing a very good application on, let's say, Python. Something, let's say Python something. Okay, so he have a computer where he basically installed the OS, and where he installed the Python platform, where he installed we developed the code. Like, there is a lot of things he has configured here, right? So what is the problem here? If this code must be tested, I have to redeploy all these things. I have to redeploy all these things on the tester's machine also. I have to reconfigure, reinstall. I have to redeploy all these things again on the other machine. Again, after this, now there is a operations team. So there also I have to deploy it again. So because of that reason, I have to redeploy it multiple times. Okay, the application platform must be reconfigured and redeployed many times whenever you need. Now comes the worst part. Now poor, okay, now we have a developer. He developed this application using the Linux OS. Okay, he has developed the application here, which is in Python on a Linux operating system. But your client is basically using Windows Server. So what happens there? There is a platform incompatibility, right? There is a platform incompatibility. Like this, there are many challenges if you use a big technology called as virtualization. Okay, see, this all these things are solvable, but still, it take a lot of effort and time and all. Now in almost every companies we go for agile model. Yeah, license cost, see, that's also very important thing to add up with this. For every OS you have to get a license. Okay, then the agile model is the basically what we have, most of the companies nowadays follow. And in that case, where we go for agile and DevOps, how can you basically work on it in a this much slow pace? You have to basically have a performance increase, right? That's why we cannot go for a virtualization in every case. That is where the technology called as containerization will come in picture. Okay, that is where the technology called as containerization will come in picture. Okay, now I will show you the concept of containers. Yeah, perfect. Just before that, team, then just okay, I was, yeah, Pratik. So you answering your question, Pratik. So when the v motion happens, it is taking the image of the VM, it is taking the image of the live VM plus the memory state of it. That's what happens. Okay, it is taking the image of the VM plus the memory state of it. That's how the memory state and the VM is actually, they move to the next particular physical machine. That's how they are able to manage it. Clear?
Yeah, awesome. So that's basically what I wanted to know. You know why?
Yeah,
Because
yeah,
coming
it's
from
obvious, right?
yeah, like why I asked this question, just to get a clarity, and also coming from security point of view, like if we
Hmm.
are only putting the control on the VM and
Okay.
a vMotion happens, then the basically the security of data can, is right now a question.
Yeah, that is why we always go for a live memory also. They take the live RAM status as well when they try to move it from one system to another.
Got it. Perfect. Thank you.
Perfect. Yep. So team, this is the drawbacks of VM, and we are done with the VM part. Okay, team, tell me, do you have any doubts in this drawbacks of this VM or anything like that? Any queries regarding this? All good? Perfect. I'm trying to explain in a very simple way, team. Okay, this is about the VM concept. Okay, these are the common challenges which we are having regarding the virtualization. Okay, now we have to discuss about something called as a containerization. Now let's talk about containers. It's a really interesting thing, containers. Okay, like the same way we say that containers are now the easiest way to deploy something. Okay, for example, for example, I will tell you the key difference between this first. When you go for a virtual machine, see this very carefully, team. When you go for a virtual machine, you have a software called as a hypervisor. When you go for a containerization, you will go for something called as a containerization platform. This is what we call as a container engine. Okay, we'll call it as container engine or containerization platform. So when you go for a VM, you have a hypervisor software like VMware, ESX, etc., which I showed you. And when you go for a Docker, you have, or basically when you go for a containers, you have something called as a container engine. There is one small difference. So team, what are the two types of hypervisors we have? Type 1 and type 2, right? And what is the benefit of type 1? No host OS, no OS we have to install on the right, no OS on the base computer, on the physical computer, right? But at the
Damn
same
it.
time, yeah, but if you go for a containerization, it is mandatory for you to have a host operating system. That means that this is my laptop, or this is my server, whatever it is, laptop or server, anything. On top of this, it is mandatory for me to have something called as a OS, like it can be Windows or Linux. It doesn't matter, anything is fine. Linux is preferred, but anything is fine. On top of it, I'm installing a software called as a containerization platform. Okay, it's a very simple thing. I will show you the installation part step by step, so you'll be able to do it with me also if you want. Okay, the
So
next thing,
it's like the type one hypervisor, like, right?
it's like a type 2 hypervisor because we have to have a host OS on it.
Type two. Type two.
Yep. Now the next thing, when you go for a virtual machine, it is mandatory that you have something called as a guest OS. That means that you have a separate operating system for your, this is your VM. Okay, this is your VM1, this is your VM2. So in your VM, what we have, you have something called as a guest OS, the guest operating system. But if you go for a containerization thing, the best part is that no operating system. That's the best part. No OS on the containers. Now the question, so Krish, if there is no OS in the containers, then how it works? Okay, that is the best part. The containers don't have any OS. So what they do, the containers use the host OS kernel. That means that the containers is just standing on top of. Okay, I'll show you that, team. Sorry.
Quick question. Quick
Yeah, tell
question.
me. Tell me.
Can you go back to the previous slide if you don't mind? Previous slide.
Yep.
Yeah. Here, for example, in the same such scenario, like if the OS operating system OS is crash here, so
Okay.
similarly we have a cluster concept similar like this, or
We have to make a cluster. We have to make a cluster. Otherwise, it will crash the entire things. Yes.
so
But it is
okay.
easy here. But it's easy. That's a difference. Like if you go for a containerization, it's much more easier. That's why we can go for it. I'll show you that. Okay. Don't worry. Yep. So team, the first thing is we have to have a computer where we have to install the operating system. Like it's mandatory to have OS like Windows or Linux. On top of it, we have to have something called as a containerization platform. And the containers are like this. These are all containers. But the difference is that when you go for a container, containers don't have a separate OS. They use the same OS which is underlying. Okay, they use the same OS kernel which is underlying. So for basically here what happens, so here if I'm having a OS, okay, this is what used by both of these containers. Okay, this is what used by both of these containers. Now there can be a question, so Krish, if this particular OS is of Windows and my container application is on Linux, how can it work? The reason is that when you go for a container, the best part is that, okay, when you go for a container, the best part is that whatever files you need for the container to run, okay, whatever files you need for the container to run is there inside the container itself. Okay, so whatever files you need for the container to run, irrespective of the OS which is underlying, whatever files the container need to run is there in the container itself. So what is advantage there? So the containers are self-sufficient. The containers are self-sufficient and portable because we are not relying on underlying OS. Like for example, let's say now this is your container, which is basically working on underlying Windows OS. Tomorrow you're taking this container to a machine which is a Linux OS machine. That will work because we are not worrying about the underlying OS. I'm just using a OS kernel, but this particular container is having all the necessary files to run the container inside it itself, but not the complete OS. Okay,
That means
that's why
here
it's much
each container will
So,
have their own kernel setup and all? Kernel?
each container have, see, they will use the same underlying OS kernel, but the difference is that each kernel, container will have the necessary binaries or library files for that application or the thing you want to run. Got it?
See, let's suppose I'm using here the operating system Linux. Okay.
Okay.
On top of it,
You're
uh,
echoing. You're echoing. Yeah. Sorry. I guess your voice is
now
echoing,
okay.
bro. Yeah, fine.
Yeah. See, basically, the underlying, let's suppose the underlying OS is a Linux OS. On top of
Okay.
it, we have installed the Docker
Okay.
engine. On top
Okay.
of it, I have configured the containers.
Okay.
Okay. So
Okay.
let's suppose you are using a Python here, an
Okay.
application.
Mm-hmm.
When I move this particular containers to
Okay.
another
Okay. Fine.
Docker containers where I'm using a Windows.
Okay.
Okay, so
Okay.
as you said earlier example that there is a platform incompatibility, whatever you told earlier. So
Yeah.
in this case, but the underlying OS is Linux here. But if you move on other Docker side, the underlying OS is Windows. Then how this
Okay.
differences can be eliminated here?
Got it. So here what happens is that you can see this binaries and libraries here, right? So this binaries and libraries contain the Python you need, first of all. Okay. Second thing, whatever things this Python need to run, irrespective of the OS, like like for example, let's say this Python needs some specific kind of files, which is there must be in Linux or there must be in Windows. That is, but that particular specific files are there inside this particular container itself. So because it is there in the container itself, what happens there? Even if, and also the container itself is a self-contained thing, so because of that reason, even if you're moving from Linux to Windows or anything and vice versa, what happens, as it is self-sustained, as this container is basically having all the necessary files on it for that particular platform to work, we don't have to worry about that particular underlying OS. So now let's say my machine is Linux, or let's say my machine is Linux where I have a container, and when I'm moving this particular container to your machine, you are getting the container which is completely self-sufficient. You need a platform to run. That's all. Got it?
It is a platform OS agnostic. The platform
Yes,
agnostic. The
it's
containers.
completely, yeah, exactly.
So Chris, in VM we have hypervisor. In containers
Okay.
we don't need hypervisor.
In containers, instead of hypervisor, we have called something called as a containerization platform. Here we have something called as a containerization platform like Docker, Kubernetes, LXC, OpenStack, OpenShift, etc. Okay.
Okay.
The interesting part is here in the
Mhm.
virtual machine also we have the all the binaries, whatever the binaries is required.
No. The thing is that, but still, these binaries are only for just the application configuration, not the complete binaries and libraries which you need for the OS and all. But here what happens, this application which we're hosting, plus the Python or Java or whatever you need, plus those additional files which is required for this to sustain is already there. I will give you a simple difference. See, now I'm showing you an example here. Okay, I'm showing an example here. Just give me a second. If I'm searching my, see, you can see that there is a lot of process running in my computer now. See, okay. But if you search, if you type in the same in a Linux container, okay, if you type in the same in Linux container, you will see that nothing will be there. Okay, the same thing, if you basically search in a Linux container, you will see that nothing will be there inside it. Like only one or two processes will be there. For example, I'll show you the thing in a real-time scenario. So now I'm running a container team. I'll teach you how to run a container. Don't ask me how now, because I'll go teach you that. Just I'm just going to run a simple container called as let's see, CentOS is good. I have it. So team, oh sorry, this is a different machine.
All containers requires a virtual machine, right? On top of the virtual
No need,
machine only
no
we
need,
are
no need.
taking this container.
No. You can have installed on live machine, but here I am just deploying. That's all for my sake of training. That's all. See, this is now I am inside a container. Okay, I'm inside a complete container. Okay, so you can see the process. See, only two process. See how much memory I saved there. You have seen that if I go for a normal, this is a normal computer. Okay, if I see my memory, see all these things you see here. It's not over. If you search, you have more things. You have more and more things. See, if you put space, you can see a lot of things. See, there's a lot of things running in my server. But if you go for a container, there's a container you're seeing now. See, only two processes running, nothing more, only two processes. So there is no complete OS there. So because there is no complete OS there, it saves a lot of time, effort, money, and all of these things. Okay, clear
Where
now?
exactly this particular container is taking the resources, underlying
Yeah,
hardware?
I'll come to that. I'll come to that. Yeah, it's all these things are working for underlying hardware, but the advantage is that it's much less than the virtual machines. Got it? Because let's say now this particular virtual machine is taking a 8 GB of RAM. The same application or platform you want, if you deploy in a container, it may take 1 or 2 GB or maximum 3 GB or let's say maximum 4 GB as per your requirements. It will not go beyond that because we are saving that resource on the OS because there is no OS in the containers. Got it?
Yeah, that means this particular containerization is only for development and testing or also on the production?
Complete for production also. We are using it in production, development, testing, everything. Okay. Yep.
Okay.
But see, but there is, there is a lot of things we have to keep in mind also while we'll deploy it. I'll come to that. Yes. All good, team? Yep. So now I'll just go back to a few more things on this and I'll start deploying the containers. Okay. So don't worry, from today and tomorrow, I'll show you all the basic commands and all. Don't worry about that. So containers share the host OS kernel. That means the underlying OS is there. So let's say, for example, team, don't bother about Windows or Linux. It's not running on virtual machines. You can basically have it on a laptop, in your mobile phone, sometimes in your server. You can basically install the container on your Windows or Linux or like the Docker platform or Kubernetes, whatever it is. And on top of it, you can install any containers you want. Okay. And there is no complete OS like the virtual machines. In the containers what we use the same OS which is underlying for all the containers. But there is one problem. We have now. These containers are very limited. It's more secure and all, I agree, but still, let's say if an attacker is able to compromise one container, okay, an attacker is able to compromise one container. Through this container, if the attacker is able to bypass your controls, and if he is able to enter the physical OS somehow, okay, if the attacker through the a container or somehow, if the attacker is able to compromise the OS, then it can basically in turn compromise the other containers as well. We call it as container escape. Okay, like in VM we have a VM escape technology concept, like here we have something called as a container escape concept also is there, just for your information. Okay, that's it. Okay, that's about the basics of containers. Now there is a question. So Chris, you talk about containers, so give me some example of containers. The answer is that if you want to create a container, okay, there are many technologies or many platforms available out there. The most common platforms, like a lot of things are there, you don't have to basically worry about it nowadays. You get many platforms or many container platforms in the market. For the most common used one is Docker. Like Docker is the most favorite one for everyone, like it's very user friendly. And then you have something called as a Kubernetes. It's a more advanced kind of Docker kind of thing. Like if you want to use a little bit more than Docker, plus you need to go into a wider perspective, you can go for Kubernetes. I'll come to the application part of it tomorrow, don't worry. Then we have a LXC, I guess. We have a OpenShift, like we have a ECS. A lot of things are there we can basically run. Okay, so we are discussing today the Docker thing, and all these rest of things I will show you in
What are
upcoming
these?
webinars.
What are these?
These are different containerization platforms like Docker. Okay, these are
So
different containerized. Okay,
these are platform to create containers, right?
exactly. Like for example, these are different platforms for creating containers, but each of them are having specific capabilities. Like for example, when you run a container in Docker, you have some limitations that can be overcome by Kubernetes. If you want to basically have a support from enterprise, you can go for OpenShift. Like that, there are many different functionality differences there, but still all these things are designed to run for containers.
I believe
Krish,
the
sorry to
most of
interrupt
the
you.
banks they are
Krish, sorry
using
to interrupt
OpenShift.
you. Is it based on that different vendors? The name is varying.
Yeah. See, Docker is by a organization. Kubernetes is by Google supported. Then we have LXC, and then we have OpenShift by Red Hat. This is by Amazon. Like it's all by different vendors
Concept is same. They are calling in a different name.
with different capabilities also. Yes.
Uh,
I think in the banks and all, they're mostly I saw OpenShift is using actually.
Not like that. See, what I feel is that uh, even I also feel okay. There is a lot of companies use Kubernetes. So team, that is a mindset which I always create for everything. Okay. So when you go for banks or when you go for any industry, I have seen that they will either use Kubernetes or OpenShift or Docker as well. But it's it's varying. Like based on, like if I feel for my particular requirement, if OpenShift is good, I'll go for that. Else I'll go for Kubernetes. It's always up to you based on the requirement. We will go for either one. But the market share is basically much more on Kubernetes only. Okay, that's as of now.
That means based on the use cases, business use
Based on use
cases.
cases. Yeah, exactly. Yes. Like when there is a one of my client is asking me, Krish, which one do I have to go for? Can I basically do a container on Docker or Kubernetes? I will not say okay, we'll go for Docker always. It's based on the use case. I'll listen to all the use cases he's having, and I have to decide whether containers are suitable for it. There's a lot of problems also with the containers. Like we have benefits, but we have problems as well. Okay, that's what we'll discuss.
Chris, if you don't mind, by end of tomorrow, I would request you to share some use cases by the end of this session. Thank you.
Yeah, definitely, sure, no problem. Okay, team, let's go for the Docker guy. Okay, Docker is a very common platform in the market now. Like Docker is a containerization platform which is basically free and open source. Basically many people are using it. It's really interesting as well. Like Docker is something which is very interesting, and nowadays many companies are using it. I'll show you that. See this docker.com. So if you basically go for a Docker Wikipedia, you can see there is a lot of things here. See Docker Wiki. Okay, Docker is a service that uses OS level virtualization. See, when you go for a normal virtualization, we call it as a hardware virtualization. If you go for a containerization, you call it as a OS level virtualization. Okay, so basically this is a tool called as Docker. So it's available by many companies using it, and this is one of the favorite platforms by many companies because all the Kubernetes and all these things are built on Docker only. Okay, that's it. That's a main reason why we go for Docker. See, it's now supported by many companies and worldwide used, and we have a 30 million plus developers working in Docker, plus 7 million applications now hosted in Docker and running in production. Okay, and it's very easy for us to manage and maintain Docker, even if we have a lot of drawbacks as well. I will tell you what is the limitations of Docker and how to overcome the limitations as well. Okay, first of all, let's see how to install the Docker platform. Okay, it's a very interesting thing. I'll show you how to install a Docker thing. So for the sake of convenience of everyone, I'm going to install Docker on a Linux machine because it's more, I'm more friendly with Linux. Plus, this container platforms are always, good with Linux. That's why I'm using it. So does it mean that, Krish, can I go for Windows? Yeah, of course you can go for Windows or Linux, but I am personally using Linux here. Okay, that's it. So if you want to install Docker, it's a easy job. And one more thing to add up. So Nakrish, where can I learn Docker and how to the commands and all? So team, my favorite platform for learning the Docker is what we call as a Docker documentation. I'm a big fan of documentation always, but still, see, if you want to install Docker, they have a complete steps, commands, everything here. So I would like you to go for this one. Okay, so let's install the Docker. So before you install Docker, the key thing is that if you have any previous versions of Docker installed, it's very challenging because you will basically find a lot of errors. So to avoid that, you have to remove if something is already installed. And if nothing is there, okay, you can either you can type like this, install docker.io. Okay, it's a basic tool, that's all. See, very simple team. All you have to do is just go to the Linux machine. You have to first of all, no, you can just see if you want to see if Docker is already installed. What we can do is, let me show you, please wait. If you want to see if Docker is previously installed or not, all you have to do is just go to the machine and type Docker space -- version. See, it's now showing Docker not found. See, it's showing Docker not found. Okay. So like, for example, there are two ways for it. Okay. If you want to see if Docker is installed, either you can type Docker space or you can just check Docker space -- version, or you can try to run a container. Like, just in case if you want to know if it's working or not, you can basically search or try to run a simple container like hello world container is there in Docker. So like this, Docker run hello world. I'll show you what is this. Don't worry. See, it's showing error. Now what I'm going to do is, team, before installing the containers on Docker, you have to update your OS. So like if I want to know what version of OS I'm using, just type uname -a. This is a basic command. You can see that now I'm using something called as a Ubuntu Linux. Okay, I'm using a Ubuntu Linux. So in Ubuntu Linux, what we have to do, if you want to install Docker, very simple. Just go to this particular thing and type in this first command. What is the use of this first command, team? This command will update all the list of repositories on your system. Like, they will basically search for all the softwares in your computer and they will search for the updates of the versions. They will just refresh the application cache. That's all. Okay, so I'm just going to do that. And when you do it in your computer, it can take some time because this is a bit they are now scanning the repositories for the latest updates on softwares and all. It is mandatory before you do this thing. Okay, now it's very faster. It's already done. Okay, they have now checked for Ubuntu machine and they have now found there is nothing new. It's all these things are there. Now the next thing is that you have to basically install these things. So if you want to install Docker, it is mandatory for you to have these things as a part of it. Yes, it's not like Windows Update. See, if you want to have it like a Windows Update, you have to go for upgrade, app to get upgrade. But here it's like a refresh, that's all. Okay, now see this, team. So you have to install these softwares. So these softwares or these prerequisites are mandatory for installing Docker on Linux. So now you are saying, Krish, it's too tough. In Windows, do we have the same steps? Not at all. If you want to install this on Windows, it is much more easier. Okay, like install Docker on Windows. If you site does install Docker on Windows, it's very easy. You can download the exe file and install it. Okay, see, it's very easy to do that. Okay, but there is some challenge I'll tell you in the next upcoming lectures. But anyway, I'm just copying this thing team. It's very easy. I'm just copying this team. I'll just install it here. So they are telling me that all these things are pre-installed. Okay, all these things are the tool called as curl, the GNOPG, LSB release, and all these things are pre-installed. These are just some prerequisites for installing Docker. It's already installed. Okay, that's it. So the next thing is that let's go for the installation part. So you have to just add the Docker's information in the Ubuntu repository. So just copy this thing and paste it in the Linux machine. So you don't have to do anything, like, the steps are not tough because this is something which is pre-configured. You can just copy and paste from the official Docker website. You can copy and paste. So there is nothing, there is no other detailed job you have to do here. Just copy and paste the commands we are having. See, it's done. Once the prerequisites are met, you have to install these things. Okay, you have to install these things. See, sudo space apt-get install docker ce CLI and container d dot in the okay, that's it. This is what we can do actually. Okay, so it's very easy to do that. It's not a big deal. Okay, or let's say, Krish, I cannot basically waste my time on this, or I cannot basically do a lot of steps like this. So what I can do is I can do something called as a Docker. There is a multiple versions like Docker Enterprise, Docker, things like that. I am showing you the very easy thing. Okay, so I can just copy this Docker thing, this command. This is the command to install the Docker. Okay, this is a command to install the Docker. So I'll just copy this command team and I pasted this command in the command line here. Press enter. Let's see if it's working for me. Okay, if you get this error, very simple. If you get this error, very simple. Just type docker and hyphen version. It's not showing. See, there is an easy command nowadays called as apt install docker.io. See, apt space install space docker.io. You can use this command called as apt space install space docker.io. So you just press type Y. They will do all the operations and they will install it for you. See, it's very easy. These are not a big deal team. These are not a big steps. It's very easy for you to do because everything is pre-configured there. See, now they are taking all the containers, everything there by default. So what are the commands I have used? So the easiest way is that team, you can first of all type, if you're using a Ubuntu machine, okay, if you're using a Ubuntu machine, first you can type sudo space apt get update. Second is sudo space apt install docker.io. This is basically enough for Linux machine. Also, if you go for a Windows machine, you can download the exe and install it very easier. Now, things are done, I guess. So I want to see if Docker is running. So how do I do that? Docker space hyphen version. It's showing me the Docker version. I'm not upgrading Linux. I'm refreshing the packages. That's all, nothing more. Okay. If you type Docker space hyphen version, it is now showing the Docker version. Okay. Things are working very perfectly. No issues, no errors. Okay.
So that means Suresh, we are ready now to create the container or this Docker platform, right?
100% yes. We are ready for deploying containers. And if you want to basically check that, Docker run hello world, just type this. So basically what happens is they will basically show you a very simple thing. See, hello from Docker. This message shows that your installation appears to be working correctly. The command is third one, sudo space docker run hello world. If you do this, they will tell you if we have installed Docker container properly or not. See this, hello from Docker. This message shows that your installation appears to be working correctly. See, to generate this message, Docker took the following steps. The Docker client contacted the Docker daemon. I'll tell you what is this. Then there was an image they have downloaded and they have deployed it. Now there is one more theoretical thing, very small theoretical concept I have to tell you before I start with the containers. Okay, very simple theoretical concept I won't tell you before I start with the containers. Okay, when you go for a container, this is how it works. Just for the sake of learning team, I'm telling you. So this is your computer. Okay, this is your computer. Okay, this is a computer. where you're having something called as you're having a software called as a Docker daemon running. Okay, this is a computer, and the computer is basically called as a Docker host. Let me write down here. Please wait. Okay, this computer which you see now is for what we call as a Docker host. Okay, so in this Docker host, okay, I have installed something called as a Docker daemon. Okay, I have installed something called as a Docker daemon. Okay, so basically what happens, team, so this Docker daemon is basically accessible to you. See, now how you are able to perform the commands on it. So you're able to perform the command on it by something called as a Docker CLI, which you have installed. It's basically installed as a part of the package itself. You are working on something called as a Docker CLI. See, this is what you are now using. Okay, so like you just type the command call as docker version, you type the command call as docker run hello world, all these things you have done on the Docker CLI. So basically what happens, this Docker CLI will contact the Docker daemon. Okay, they will contact the Docker daemon. This is the one which is basically talking to the Docker daemon. Okay, like this. Through what? Through something called as a REST API. This Docker server CLI is talking to the Docker daemon to REST API, REST API. And this Docker daemon helps you to create the containers. So basically the containers here, the container 1, the container 2, all these things are created inside this Docker server or Docker host. All clear, team? Now you have installed Docker properly. These are the commands I have used for installation. If you want, I can basically share this command in the chat box. Okay, that's it. And one more thing I would prefer, team, to avoid the errors or something in future. I will show you one more thing which I have done. This command is a mandatory to do if you want to avoid some errors. But even if it will work, but still sometimes I have seen some errors. To avoid the errors, you can basically use this command as well. Just copy this command and paste it. It'll work.
Krish, can you repeat this concept of Docker daemon, please?
Okay, so Docker daemon is basically something which we have installed now. Okay, so basically now what we have done is that when we install the Docker on the Docker host, there is a service called as Docker daemon running on. This is a service. In Windows, we call a service running. Okay, so we are communicating with the service using something called as a Docker CLI. So when I issue a command on the Docker CLI, it will basically pass it on to the Docker daemon with the help of a REST API, and the Docker daemon will basically use the Docker installation to deploy containers on beneath it. Okay, got
So
it?
any machine can be used as a Docker host, Chris.
It can be
Any.
Windows machine or Linux. Yeah, yes. So don't forget the Docker engine is the heart of the Docker. So basically the Docker engine is inside this. So when you communicate, what happens when you want to type it something, you just type it in the Docker CLI. Okay, and from that you can basically connect to the Docker daemon, and the Docker daemon will basically make the containers as per your request. Okay, and
Yeah,
we can
that's
have, yeah.
fine.
Tell me.
My query is something else. Suppose you have your laptop. Let's take a
Okay,
layman example. You are using your laptop, whatever the OS you had in your laptop. I want
okay,
to convert this laptop to a Docker platform, right?
okay,
So
yeah,
I want to convert your laptop as a Docker host. So whatever
okay.
you just taught, we have to do all those steps, right?
That's all. It's a Docker host now. Once you do the steps, it is a Docker host now. Nothing
Okay.
more.
And
Okay.
Docker CLI is by default available for us, right? After installation.
Everything is, yeah, yeah, yes. Okay, now what do you mean? Okay, now one daemon per one host, and yeah, you can basically what happens is one daemon per one host. Yes, exactly. That's what we do. We can create multiple containers. Yes. If you are using Windows, what we can do, team? If you're using Windows, nothing much. It's not a big deal. Download the exe file, then install it. That's all. Nothing more. Okay. It's very easy for us to work on it. Okay. That's it. Yes, yes. It's also container. Yes. Now that's about the basics of installation, team. Okay. Now the next thing is that You know how to install a Docker container now. You know what is a container now. You're good at it. Okay. Now the next question: how do you deploy the concept called as containers? How do I deploy the containers? That's the next question. If you want to deploy a container, there are some few points you have to keep in mind. For example, let's say team. Now I'm going very slowly only because tomorrow also we have a session. Don't worry. So this is my computer. This is my computer. Let's say PC or laptop or VM or whatever it is. I want to install Windows on it. Okay, I want to install Windows or I want Linux on install Linux on it. So team, from where I will do this? So if I want to install Windows or Linux on it, from where I can get the installation thing? I want to install the Windows on it, Windows 11 on it. How, from where I can get this software for it?
Either through any extra resource CD or whatever, or some
Okay,
downloaded
so
files.
basically, if you want to use a CD or something, whatever it is, you first of all you have to go to the Microsoft website, right?
Yes,
You have to go
yes.
to Microsoft website and you have to download something called as a image file. You have an image file, yeah, right? You call it as a ISO file or you have a VHD file. You have multiple, but anyway, you have to have an image file. So this particular image, okay, from there you download the image, and from this image is basically where you install the OS and all these things, right? Like the same way, if you want to install something or if you want to deploy a container, you can deploy the container only from something called as a image. Okay, you can deploy the container only from something called as a image. Say this is an image. I'll tell you from where you get it. So from this image you use a command. So first of all, you have to get this image. I'll show you how to get it. Once you get this image, you can basically make a container out of it. When you have an image, you can create multiple containers like this. So for example, let's say I download a Windows OS. Okay, I download a Windows OS or I download a Linux OS. I can install multiple computers on it, right? I can using this image, I'm able to install multiple laptops or multiple PC or servers, right? Because it's a common software. Like the same way, from a Docker image you have downloaded, you can basically install or you can basically deploy many containers. Got it, team? It's a very simple thing. So I'm going to show you from where we can get the containers. So get the images. There are two ways. The most common or the most commonly used way is called as a Docker Hub. There is a centralized repository by Docker. Okay, we have a centralized repository. Okay, repository means collection. Okay, we have a centralized repository by Docker called as a Docker Hub. Okay, it's called as Docker Hub. Docker Hub means it's very simple. All you have to do is just go to something called as hub.docker.com. I'll show you that. See, you have to go to something called as a hub.docker.com and it will take you to something called as a Docker Hub. It is nothing, it's just a repository, it's just a collection of images which we have. Okay, so basically this is basically a free platform where you can upload your container as well, sorry, image as well. So I click on export. You can see that there is many images: Alpine, Postgres, Busybox, Python, Traffic, Nginx, Ubuntu, Golang, Redis, Apache, Node.js. See, all these things you see here are the various images. Okay, are the various images. But let me show you a very interesting thing. Team, tell me some name of a web server platform. Give me some name of a web server platform. Apache. Okay, Apache. I type
Apache,
Apache.
IAS.
Yeah, I type Apache, press enter. So you can see that there is something called as a this is the Apache official image. See, this is the Apache official image. See, basically it's showing us official image. Official image means this image is basically there from the official Apache organization, the company which provides the Apache image. Okay, that's it. Okay, now how do I see if there is an image in the Docker Hub? Very simple. You can just type Docker space search space Apache. Press enter. Let's see what happens. See, team, you can see that there is many images here. See, there is many images here. Okay. Out of these things, you can see that these three things, can you notice a very interesting difference here, team? Like for the image called as HTTPD, okay, for the image called as HTTPD, it's HTTPD, it's Tomcat, it's Maven, but everything after that, you can see that there is something dot something slash that image name, something slash that image name. See, something slash image name. So what do you mean by that? That means that when you basically have an image, the name only, that means the official image, which is basic, it's completely official. Those images which are given by a third party or Krish or John or Sam or Tom or anyone outside this, the official image is basically mentioned by this name. Like for example, now if Krish is having an account in Docker Hub, okay, if I am having an account in Docker Hub, you will see it like Krish slash the image name which I have created. So anyway, what happens, team? These are the images which is official. Now there is a problem. So team, let's say for example, if you see an image here called as the good guy slash Apache, how can you trust this image, team? Can you completely trust this image? Tell me, is it possible for you to completely trust this image? It's from a
No.
third party, right? It's a third party. So first of all, the best practice is that I always prefer you go for the official images, because if you go for an official image, that is from the actual Apache organization. So because of that reason, what happens, it is very easy for you to get a more real or more genuine version of it. But if you go for the other things, you can basically search. This is basically Ubuntu based, so it won't be a trouble, but still these are not from the official vendors. Okay, so how do I know it? Just see the name. If you see something slash the name, it's an unofficial image. If you see just the name only, it's an official image. So for example, here I can show you that HTTPD,
So,
so official image. Sorry.
so Chris, whatever image you are showing right now, see,
Okay.
in last step we have installed the Docker platform, right, to create the
Okay.
container or to deploy the
Okay.
container. Now
Yes.
we are still configuring the Docker, or we are creating the containers, deploying the containers.
We are going to deploy containers. The Docker is already configured. We are going to deploy containers. So
Okay.
once we have done this, okay, once we have done this, we successfully installed Docker and it's ready to deploy your images. Got it?
Yeah. So these images are containers basically, whatever you are looking.
These images is something which will help us to create containers.
Okay.
These images
Okay.
something which can, so let's, for example, let's say now you want to, okay, let me give an example. You want to create a Python container. So if you want to deploy a Python container, first what you have to get, you have to get a Python image.
Okay. Fine. Clear now.
And
Right.
this Python image is basically you're getting from the Docker Hub. And once you use this image to deploy a container, it's very easy. Okay, that's it. Perfect. Now let me show you that one second, team. This is yeah, you have to no see, there is no container now. As of now in my computer, there is no container now. See, how do I know if there's a container running? I don't have a container. See, no container is there. All I have done is that I have installed Docker. If you want to search the Docker Hub, okay, what is a Docker Hub? It's a centralized repository. If you want to search Docker Hub to see if there is any kind of images like Apache or anything like that, you can basically either go for it in the browser and search like this, or you can use a command called as Docker search space the image name, like the let's say for example Python. So basically what happened, they will show me the images of Python. It is a lot. See, all these images are basically by for Python. See, these are Python. Okay, so now coming back to topic, team, just give me a second. Let me just move this to a different browser window. Yeah, much better now. Okay, so team, now I see you can basically see a lot of images here. Okay, see, this is the official image. That means what? This image is basically official. This image is basically given by the official Apache. But if you go for, if you scroll down, what happens, team? There is an image called as Apache Spark. So this is basically given by IBM, not by official Apache. This is basic. So basically, it's a customized image for your requirement. So if I go for some further pages, see, you can basically see a lot of things here. I'm going to very long back. See, there is a Apache / James. See, Apache spot demo. See, there are many people who is providing it, but these are from a third parties. These are not from a official Apache. But you can basically download the image, or if you want, you can create an image also. But if you want to create an image, you have to write a code on that. I'll show you. Tomorrow I'll show you a very simple glance of creating your own container or create your own image. So as of now, team, I hope you are clear with this. Now this is basically how you get the image. Okay, so don't forget, just for understanding, team, understand that if you want to create a Docker container, now we have installed the platform. If you want to create a Docker container, first thing what you have to get something called as a Docker image. So from where you can get the official images from a platform or a centralized repository called as Docker Hub. If you want to go for it, just type hub.docker.com and you will be able to get the images. So from here, you can basically download the image you want, and using this image, you'll be able to deploy the containers. Also, if you want, you can build your own image, but there are some constraints. I'll tell you tomorrow. Okay, that's it. This is the basic. Okay, now let's do one thing, team. Let's run a small container now. Okay, let's run a very small container now. First of all, I want to run a container called as Apache. I want to run a container called as Apache. I open this. I scroll down. So the command is docker pull httpd. So what is this command? If you want to download a container, the first thing you have to do is you have to download the image. Okay. Now my requirement is that my company is telling me, Krish, deploy a Apache web server. So if I want to download Apache web server or deploy Apache container, first thing is that I have to download the Apache image. So the image name, what you call that Apache image? The image is called as httpd. So what you have to do is just type docker space pull space httpd. So when you do this, are you downloading the container or the image? Tell me, are you downloading the container or the image?
Image.
You're downloading the
Image.
image,
Yeah.
just a template. Okay, image. I press enter. Now they have downloaded the image. Let's see if it's download. Let's wait for it to complete. Okay, it's now downloaded. But how do I know if it's downloaded? Type docker space images. If you type this command called as docker space images, you can see that there is my container which is downloaded, my image which is downloaded called as Apache. See, this is the container which I have downloaded just now. Okay, this is completely fine. This is a different thing. Yeah, I'm coming to that. I'm coming to that. Okay, I will go step by step. So first of all, I am downloading an image called as Apache. The command I used is pull space httpd. And once I pull it, what happens, team? I can see the images in my local. This is the image in my local laptop. See, Docker images. I can see there are 2 images now. Okay, but there is one more point. Can you see this message here they have showed me? Using the tag latest, using the default tag latest. That means that whenever you are downloading any image, okay, whenever you are downloading any image, if you don't specify the version you want, okay, if you basically don't specify the version you want, it will download the latest version. All good, team? So I'll show you once again. Now, if you basically click on view available tags, see, now in this section, can you see a message here called as view available tags? I click on this. See, these are the versions we are having. So basically what happens, team, this is the latest version. If you want to go for previous versions, you can go for different names like Bullseye, 2.4.52, 2.4, Alpine 3.5 on Pi, Alpine. See, these are all different versions. These are all older versions of the Apache image. If you want to get the latest image, just run this command. If you want to download, so team, can you tell me how can I basically download this image? How can I download this image, team? 2.4.52.
You will have to specify the version over there.
You have
All
to
right.
mention the text
Yeah.
name then.
Sorry. Yeah. All you have to do is Docker space pull space Apache space, sorry, colon 2.4.52. 2.4.52. So basically now what happens, team? Now they are okay, it's completely fine. Okay, so if basically if you get an error, okay, yeah, it's completely fine, because if you get an error like this, it's completely fine. That is because you have that version don't exist, or that version is not completely currently available. Okay, so let me just see that. See if there is some issue, or there's, see, this is a command you have to use. Let's go. Oh, I have done, I just, yeah, let me run this once again. Now it will work. It's not Apache, it's HTTPD. I press enter. See, team, now it's downloaded. Okay, now it's downloaded. Okay, yeah, no problem. You can see now 3 images, right? So this is the latest image which I have downloaded. This is the new image which I have just downloaded. Okay, now there is a problem that people ask. So Krish, what is this created? This is created by the vendor 3 weeks back, not by me. Okay, I have downloaded this now. Okay, this is the latest version I have downloaded. This is the older version I have downloaded. Okay, now I want to download a different container software. Let's do it, team. Let's download a different container software. Give me some other containers, team. Tell me, give me some other names. Okay, can we download this? Let's say
Kubernetes, huh?
no, that's a different thing. I just want to have an image. Yeah, we will download something called as a CentOS. Okay, it's a OS, complete OS, right? We will download an image called a CentOS. It will come. This container contains OS. Yeah, it's a CentOS image. So first of all, Docker pull CentOS. You have not created a container now. You have just downloaded the image. So if you type this, what happens? They will download the latest version. So what if I want to download the previous version? Just click on this container name, and you can click on view available tags. So just use the tag called as CentOS 7 or CentOS 8 point something. See, there are many things you have here. You can basically use any of the tag here. Just copy it and it will work. So as of now, I want to have a latest version. So I click on enter. So I hope tagging is clear to you now. Tag means the version tag. So or tag means multiple versions of containers. Okay, that's it. So Docker images. See, now you can see that my CentOS image is downloaded. Now this is how you download an image.
Krish, quick question here. See, earlier you downloaded Apache, right?
Yes.
See, once, for example, earlier we said this containers not required OS, right?
Okay.
It will, whenever you create a container, it build with some binaries and all.
Yes.
So, for example, you want to install Apache, so you will be building on top of the existing container without this central OS or whatever OS, correct?
Nothing. See, this is entirely different. So this is an independent thing. If you click now, if you now run this image, it will run by itself. There is no need of underlying image or anything like that. I just downloaded a different thing. That's all. If you want, you can use it or not. That's all.
Now, when do we go for this? Because my little confusion, like here.
Okay, I'll do one thing. I'll do one thing. See, what I'm going to do is I'm going to remove the content. So if you want to remove an image you have downloaded, okay, I want to remove an image I have downloaded. Docker space RMI, that is a command used to remove a container or remove an image, not a container, image. If you want to remove an image which you have downloaded, type Docker space RMI space the image name. So now what happens? It is now deleted. So if you basically go for Docker images now, see, it's gone now. And there is a, see, now you have downloaded an image called as HTTPD. What is this? Apache. So if you click on, once I show you how to run an Apache container now, it doesn't need any OS. It doesn't need any operating system. Got it?
So Krish, from images you get the container, is that right?
Yes. If from images you can create containers.
Yeah, correct. You can create containers from the image. Okay.
Yes.
And then you don't require the image once you have created the.
No need, because that is for different way, other part of it actually. Okay.
Just one question. Just one question.
So,
What about how do you update those containers?
Like, in the sense
Like,
means?
in terms of you want to patch them or you want to do security updates.
First of all, when you say patching, the key point is that you don't have a OS to patch there. First point. The second thing is, if you want to patch it, you can basically get a terminal for the container. I'll show you that. You can basically create something called as a container terminal. Once you basically have a container terminal, you will be able to log into the container and patch it whatever you want. Okay, that's it.
Right. So when I mentioned patching, what I was meaning, like, because your container still contains libraries and binary files, correct? Let's
Yeah,
say there
yes,
is a
it's
one,
possible. It's possible. Yes, you can
you will show
basically
that, right?
yeah, you can basically get a terminal or command line for the container, and in the command line you can basically do the patching and all these things.
So do we
You will
have a
show that?
snapshot also available here? Like we have snapshot in VMs. So can we take snapshot of container and then replicate those snapshots? Or
Of course, yes, but still we don't have to use that because we have many other methods on this. We can basically do it more easier. I'll show you that. Yes, okay.
okay.
And team, just one more thing to give you a clarity, team, all of you. So let's say, for example, team, I have seen many people have one confusion again. Just I'm telling you once for the clarity. So now I want to install a Windows 7, Windows 10, let's say Windows 10. So you go to Microsoft.com. Okay, you download Windows 7, Windows 10.iso. Okay, this is what we call as a image. So team, how many computers I can install this image? How many computers I can install this image?
And numbers of
N
yes.
numbers, right? So I can
Yeah.
basically deploy computer number 1, computer number 2. I can deploy multiple, I can use create multiple Windows servers with this, right? Or Windows 10 with this, right? The same way, from one image, if you want, you can create 1 or 2 or 3 or 4 or hundreds of containers if you want. It's completely fine. And we will be able to manage the containers more effectively once I teach you that. Okay, don't worry.
So if we downloaded images of Python, so we can create a multiple container for the same, right?
Definitely yes.
Okay, thank you.
Okay, if
Clear
there are
now.
multiple in the same
I
name,
have a
then all of them
question.
will be. No. So basically, team, there will not be multiple container with the same name. You will never be see because what happens? You have a tag, right? So basically, whenever you when if you like team, let's say my question is that. So now there is a question I got in the chat box. If there are multiple images with the same name, then how can I basically remove only one team? This is the command I use to remove the CentOS container. I want to remove this image, CentOS image. Okay, if I want to remove this image, what is the command I have to use? Tell me, team. From this command, can you tell me what is the command I want have to use to remove this image? Docker,
HTTP.
The same Docker, RMI,
Docker,
and
RMI,
HTTP
Center
RMI,
HTTPD,
followed
HTTPS version.
For
and
dot
then
Colon
two
version.
colon
version name
2
Version name.
4.52.
2.52. If I don't mention this, which will be removed?
yeah,
The
Guess
latest
what?
latest.
will be removed.
The latest
That's
one, basic. Latest one.
exactly. Now you're good in this. Perfect. Any other doubts, team? Tell me.
Yeah,
So,
if
Chris,
you want to see the list
Chris,
of
can you just,
containers, how to see?
Chris,
Sorry.
can you deploy a container from the image? Did you show it, or are you going to show it now?
No. I'm yet to show you that. I'm
You have to
just
show
I
going
it.
want to
slowly.
see the list of
Yeah.
containers.
Yeah, like if you want to see the images, you can see that there is 3 images now. So if you want to see if there is any containers, just type docker space run docker space ps. If you type docker space ps, you can see there is no containers now running. That's why it's not showing something. But I'll show you my another server. In this server, you can see that docker space ps. You can see that there is one container which is currently running. See, it's now currently running. But if you go for this machine, you can see there is no container now running. Okay, now let me show you how to
Krish,
create a
I have a
container.
question.
Tell me,
Krish, I have a question.
tell me.
I have two questions. One is now you just showed us how to download a image from Docker Hub, and these are
Okay,
all the images
yes,
for example, from Apache or Ubuntu or
yeah,
CentOS. Now, if
yeah.
I want to download or pull an image, which is probably somebody like me has pushed it. So how do we do that? We add those slashes there.
So let's say, for example, now my problem is that, okay, let's say that's a very interesting question. So I want to download an image called as Apache, like you said. Okay, so in this, I don't want the official image. I want to use an image like called as, let's say this image I want to download, or let's say I want to image that image. Just give me a second. Let me get a very light image. Otherwise, my space will be completely gone. Yeah, I will take an image called as this one. Like it's called as find racked.cn.customer. I want to download this one. So basically, what I have to do is just click on this. This is the only command you have to use. The command is already
Okay.
here. See,
Oh,
docker pull
okay.
the name slash this
Got
one.
it.
That's all.
Okay, got it. The next question was, if you were also presenting a slide PPT.
Okay.
Now, yeah. So right now, what we're doing is we're creating these images
We are
by
downloading
pulling.
these images. We are downloading
Yeah,
this
we're
image.
down exactly downloading from Docker Hub. Now,
Yes,
if I have to create my own image, do I
it is
need to
possible.
really do I need to create it from Docker file? How do we do it? How do we do it? Do we
No,
create an image first, push it to Docker Hub, and then pull it
no,
from
no, no,
Docker Hub? How does it
no, no,
work?
no, 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 no. We can basically make image, but that is a bit different process. I'll show you that tomorrow. It's fine.
Okay, sure.
Because I won't teach something else, and only it will be easy to understand.
Got it. Thanks.
Yep. Now let's do one thing, team. Just we will run a container. We are going to run the first container. Okay. So now we have an image. Okay. Now I want to run an image. Docker space run space. This is a command which we use to run an image. Okay, or run a container. So for example, if you type docker space images, you can see that there is 3 images now. I want to run this one. So if you want to run a container from this image, if you want to run a container from this image, you have to type docker space run space the image name. Okay, so what I'm doing is now, so you can type docker space, okay, run space the image name. Okay, so if you press enter, okay, it's now running. But I will tell you how to log into it, how to basically see it. There's a lot of commands you have to use in between. Don't worry, I'll show it tomorrow. But as of now, see, it's showing docker space run space http is a command which we use to run a container. Now
You are
I
running
want
it,
to see,
running a Docker
just give me a second,
or,
team. Just give me a
or
second.
deploying?
Just give me a second, team. No, I am creating a Docker container from my image now. So once I type the command called as docker space run space httpd, it has created a container called as httpd now. I'll show you that. Okay. I'm going to take a different browser tab of my container, and I'm going to show you that. Just give me a second. This is the same OS which I am having. So see this, team. If I type docker space ps, can you see any containers now? No, there is no containers now. I'll tell you the reason. See, you run a command called as docker run httpd. So basically what happens, team, now what we have done is that we have deployed a container from the image called as httpd. Okay, but if you type docker space ps, it's not showing my container. See, it's not showing any containers now. I will do a different command, docker space ps space -a. So they are telling me that there was a container running in this computer, but it exited 52 seconds ago. Why it's like that? Steam container is, does the container have a complete OS? Team, tell me. Does the container have a complete OS?
No.
No.
No, right? So if the container want to keep on running, there must be something called as a process inside the container. If there is no process inside the container will not keep on running. So now what happens? I type docker space run space httpd. So what happens? It is now running the container called as from the image. It's creating container called as httpd. But the thing is that if you basically click on this thing called as a docker space ps, it is not showing the running containers because this is not running now. Because I have run the container, but there is nothing I have done inside this because there is no task to run. That is why the container already exited. This command will basically show us the containers which is already run and exited before. So for example, if you search this particular thing, docker space ps space -a, it's a different server. See, all these containers I was running previously. See, and this is the only container which is now running. Except this, every other container was exited previously. Got it?
So that means a container
Mhm.
having your bins and library files and your command to run, or application running on this container has been wiped off, right? Is it like that?
Now, see, there is nothing inside the container. So then how can it run? So Apache is there, but Apache want to do some job, right? If there is no job, he will basically go to sleep again. If the container will not run again. Got it?
Okay, let's forget about Apache. Let's take a simple example. Let container can have Windows, any other platform, right? Application, right?
No. Containers cannot have Windows. Containers can have Apache or Nginx or CentOS or anything like that. Any application platforms, etc.
Okay, if that application is not doing any task, it will exit it by default.
The containers will exit if there is no task running on it. For example, I'm going to, if you want, I can basically show you an example, very simple example here. I'm going to run a new container. So don't ask me this command team. I'll teach you this command in the next in the next few lectures itself. But I'm just going to run a container here called as Docker run minus uh, minus D. Minus D means detached mode. Okay, minus D means detached mode. Okay, I'm running a container in something called as a detached mode. Okay, so once I run this container, let me show you what happens. So once I run a container, just a simple container without anything on it, or let's say I'll write DT. The name is, let's say, CentOS bash. So now there is something which you see new, right? Unable to find the image CentOS locally. That means what? We have not downloaded the image previously. Do you remember that we don't have an image on CentOS, right? So now what happens, team? Now what happened was this Docker. I told Docker to run a container called as CentOS. Okay, from an image called as CentOS, I want to run a container. But Docker, when they search for it, they didn't find the container in my laptop. So what they have done, they have downloaded the image from the official website or Docker Hub, and then they have deployed it for me. So you can see that now the container is running. See, now the container is running. It's not exited. Okay, it's now exited. Is it clear, team? So let me
So
show you once again.
why it is running now, not exited? Nothing is happening at
Because
this time.
yes, it is running because I have started a process called as bash. See,
Okay,
I'll teach you what
okay.
is this. But see, now in the previous container, let's say if I type docker space run space apache, sorry, not apache, what is the name? HTTP, right? When I run this, what happened? It will run. But when you basically try to do something, it will exit. The reason is because there is no task I have given to this Apache web server. But when I basically run the CentOS image, inside the CentOS, I told them to run something called as a bash shell. So there is something running inside it. Okay. If that task is exited, okay. So if the task is exited, what happens? The container will no longer be able to do anything. See, now there is a task called as bash running inside it. That's why it was able to show me this. Okay. So team clear till now, all of you?
Okay.
Yep.
So with this command, you did two stuff, Krish, basically.
Okay.
You downloaded the image and you
And you
deploy a
install.
container.
Exactly.
Okay, with a
Exactly.
single command, two step happened here, right?
Okay, but still, team. Tell me what you understood. Okay, I'm telling you. Let's say I'm going to run. If in my laptop you see there is no other images, I'm running something called as Docker space run space. Let's say Nginx. Okay, team. What is the purpose of this command? Tell me what is the purpose of this command.
To run this application, or
This will no.
deploy a container with the image.
This will deploy a Docker container
Docker container.
from the image called Nginx, right?
Right,
So when you
right.
press enter on this command, what happens is that, okay, if that image you have not previously downloaded, like there was a previous step you have to do called as Docker pull Nginx. If this step was not done, what is this command will do? This will
It will download. It will download.
download
It will first
the
download and
image
then run.
called
Image from the
Nginx
Docker Hub.
from Docker Hub. Okay, so if what happened was, if this step was not done, if this step was not done, when you run this command, what they will do is they will do this step for you. That means that if the first step is not done, then the Docker will basically directly go to the Docker Hub and download it and then install it for you or deploy the container for you. All good, team? Yep.
Yeah, clear.
Yep. And
in this case, even if the OS also
okay,
will run and it will disappear, right? If the OS also or no?
everything. See, CentOS is like it's a mini OS which they are now providing for us. Okay, now there is a question. So how do I stop this container? Let's say, for example, if you want to see the container, Docker space page is the command to use to see the containers. But how do I basically stop the container? Very simple. So there is, before I stop the container, let me show you something. For every container, they will show you certain things. First of all, they will show you something called as a container ID. This is the unique value for the container. Whenever you are running a container, for every container, first thing what? There is a container ID. Then they will show you from which image you have downloaded this container, or from which image which you have created this container. Then what is a command which you have run in the container, when it is created, is it running or not, which all ports are open. Ports open, I'll show you in the next session. And what is the name of the container? But Krish, I didn't give a name for it. If you don't give a name for the container, they will use a name by themselves. They will use a name by themselves. For example, it's a very interesting thing. See, I'm going to my another computer. See this team. In this particular thing, you can see that there is a container name called as Affectionate Alien, a Peaceful Goldberg, Cool Feynman, Confident Hoover, Practical LS, Gifted Ramanujan. So these are various names of like some masters and all given by Docker itself. If you don't give a name for your image, Docker will give a name by itself. Okay, I'll tell you once again, team, it's a very important to understand. So this is the ID of the container. That means the unique value of the running or your container. This is the source image of the container. This is a command you have run. This is the yeah, I didn't explain that. I meant to explain it now. See, this is the time which is created. It is now running for last 3 minutes, and it's, you know, the name is stupefied pike. Okay, what if I want to run one more container the same way? Okay, if I rerun this command, team, if I basically rerun this command, my question is that will it override the existing container, or they will create a new container?
It
New
will not
container,
overwrite.
new container
New
basically.
container.
It will create a new container. Let's see.
New container.
Let's see. See, if I basically do this, you can see there are two CentOS containers now running with a two different IDs, and there is a name for it: Romantic Johnson, Stupefied Pike. See, these are just names which they have given to you. Got a team? Is it clear, all of you? Okay, now what if you want to give your own name? That's also a very important point, right? Like, what if you want to give your own name? Like, Krish, I don't want Docker to give a stupid names like this, or let's say fancy names like this. I want to give a name by myself to the container. That is also possible. If you want, it's also possible for you to get a name for your container by yourself. Okay, you can basically put a tag value there. If you put a tag value there, you will be able to do the name also. Okay, that's it.
See, for example, you're running
Okay,
a container with a command. So how
okay.
long that command runs? That is forever, or it will
Until you exit, or basically, see, let's say, let me show you a very interesting thing. Now I'm going to run one more container. Okay, Docker space run space, let's say, what is the command I will run? Yeah, -d CentOS sleep, like 200 seconds. So what happens is, now this process will be running in the container for 200 seconds. Now if you type Docker space ps, what happens? You can see there are three containers running out. See, now three containers running. But after 200 seconds, if you basically see this container will exit. Why the container will exit, team? Tell me. Why the container exit after 200 seconds?
Because you've given a command of sleep 200 here.
Okay, no, that is a command I have given, right? But after this, why it happened? Because once this particular time is over, there is nothing for the container to run, so it will
Right,
automatically exit the rule which we discussed.
right.
Got it?
Yeah.
That's it.
So Chris, here I have one question. When the
Tell me.
container is stopped, here basically when the container is stopped, means nothing is
Okay.
running. So that
Mhm.
will be count as a saving resources, hardware resources. That's count.
Not exactly. They will not take your memory. You know, they will leave the storage, maybe, but they will not take the memory because it is not utilized, right?
Okay, thank you.
Okay. Now that's about the key things, team. The next one is for, let's say, for example, if you want, see, all these are game names given by, you know, the guy itself. So if you want to give a name by yourself, very simple. I'm going to create a container with my own name. The name tag I want to give us, let's say I will give a tag. Okay, I can put a name here if I want, or I can put a name ID here also, but I'm not, it's not required. It's not a big deal, because you can, if you want, you can basically give a name for your container, but I'm not giving a name as of now. Okay, now the next thing is that how do I stop a container? If you want to stop a container, there are multiple ways. Docker stop, either you have to paste the container ID or you have to paste the container name. If you want to stop a container, you have to type docker space stop space the container ID or the container name. So I'm typing the container ID. Just I'm copying and pasting container ID. I press enter.
That would be cascade killing, Chris, because the process batch is still running. Ideally, we should first close the process, then stop the
No, that
container.
is fine. That will do in the back end. It won't harm the content. Don't worry. Okay. Because
Okay.
see, first of all, you are thinking in the perspective of OS. You have attachment towards the OS, but we are containers. We don't have attachment towards any OS. Then how can we talk about the process worrying? No worries about that. Now, let's say I'm stopping the second container also. Press enter. Now, so team, if you type docker space ps, you can see that there is now only one container running. So team, how do I see that the closed containers? How do I see the exited containers or shutdown containers? Docker space ps space minus a. If you
I
type minus a, tell me. If you
no
type,
hyphen A, it will give you the
yeah,
history.
exactly. If you type docker space ps space hyphen a, it will basically tell you all the containers now, and this is the only thing which is running. Everything else is exited. Okay, now there is a problem. You say exited, but what is a real problem? Even if it is exited, it is still running, utilizing your space, right? You have not removed it. See, you have an image. You, from the image you create a container, but in the container, if you even if you shut down the container, still it's there, right? You can see, if you, okay, what is the command we can use to start the container? Team, tell me. If stop is this, what is start? Very simple. You can just click on start, right? It will start the container, right? Okay. So what we have to do is, if you want to remove the container, like if you want to say that, Krish, I don't want the container anymore. So let me show you the containers. So I want to remove the container. What I have to do is docker space rm space, not rmi, rm space the container ID or container name. I'm giving the container ID now. Press enter. It's removed. The next container, I want to remove the next container. Copy, enter. Sorry, it's already removed. So if you want to remove the container scheme, all you have to do is just type docker space rm space the container name. Also, if you can basically type multiple IDs at the same time also, but I am not doing it now. I am removing all these things separately only. Okay, that's it.
Is it
See,
recommended to remove the containers, Chris, like
see
this?
until unless you want to use, if you want to use it again or not. See, if I don't want to use the container again, I can basically remove it.
For
Okay,
audit
but there is a,
purpose, something, or for history purpose,
yeah,
someone wants to get the back. Are we have the history or the change log, something like that?
we can keep it. Yeah, no problem. We can keep it. Okay, now there is one more thing. Team, I'm going to shut down. I'm going to remove this container. Okay, see what happens. See what happens very clearly. Yeah, you can use the container ID or name now. Okay, yeah. So I'm typing docker space rm space the container ID or container name. I'm just copying the container ID, paste it, press enter. It is showing me error. What is error, team? Read the error. You cannot remove a container which is running. So what is the first thing you have to do if you want to remove a container?
You have to
The
stop the
container
container first and
Stop
then
the, so docker space stop space.
ID.
Uh,
Yeah.
yeah, you have to give the ID of the container. Like I just copy the ID and paste it here. And then if you try to remove the container, it is removed. If you type docker space ps, you can see there is no container now running. Okay, that's it, team.